So part of the deal with these problems is you're just looking to see what words they use, because those little Q questions that we just got through doing, that was just to kind of help you know what to do when you read the different words. Y equal KX. And it explains, these are real life problems. The number of houses that can be served by a water main is directly proportional to the square of the diameter of the main. So what do I got to do is square the X. Now here's what I could do. Maybe that doesn't make much sense in the problem. Maybe I'm going to change my letters. The number of houses, so let's call houses H. The number of houses that can be served is directly proportional to, so I'm going to replace a Y with an H so that my letters match up my word problem stuff. There's some constant, and it's directly proportional to the square of the diameter. So instead of writing X squared, I'm going to write D squared. Okay? We're just going to change this over to letters that make sense in the problem. H is the number of houses served. Number of houses served. And D is the diameter, and they told us it was directly proportional to the square of the diameter. Does my equation make sense now? H equal K D squared. If I think about just translating the letters over, you can see all we're doing is our X is our diameter and our Y value is the number of houses served. This is how you're going to change this over. You're going to write what you know, and then you're going to kind of go, okay, it was houses is directly proportional to diameter squared. So we're just going to replace Y with H and X with D here. And they explain why. This is because the cross-sectional area of the pipe, and thus the number of liters per minute that can flow, varies directly with the square of the diameter. Suppose that City Water Works has a 10 centimeter water main that can supply 50 houses. Let's make a point out of this. Let's write this down. Normally I would write an X and a Y, but here my X ended up being the diameter, right? And what did my Y end up being? What did I write it underneath on the equation? What did I call my Y, guys? What's the variable there? Come on, I need your input. H. It's the number of houses, right? Okay. So if I write it like that, they're telling me my diameter is 10 and the number of houses served was 50. There's a point that I can use to try to figure out my equation, right? So they're telling me what kind of equation I need and how to write the general thing of it. And then they're going to give me a specific point, and I got to make sure that I got these variables all matched up right. Okay, so if H is equal to KD squared, let's plug it in. H was 50, thank you. And my D, I got to square it. I'm going to plug it in, but then I got to square it. My D was 10. Okay, so let's see. 10 squared is 100. So K times 100 would be 100K. Ooh, I almost know what my K is. How am I going to figure out what my K is? Yeah, just get K, solve for K. If I want K by itself, I'm going to circle it. Shouldn't I divide 100 out of both sides to get K by itself? Mm-hmm. What's 50 over 100? Well, it's 1 over 2, right? It's in a half if you reduce that fraction. Oh, guess what? We know our equation now. That's a 2. I just can't get it to fit in there. Let me write it over here. So if K is a half, I'm going to need a new slide here because I'm out of room. And I had H equal KD squared. Now I can put that K in and I've got my equation. H is a half times diameter squared. So on A, when they want you to write the particular equation, this is what the answer to A is. They just want you to write the equation that you could use to plug in any diameter and tell how many houses it would serve. Remember, my points are, instead of X's and Y's, what I decided to use because of the stuff in the formula were the diameter is my X and my houses is my Y. I started with that Y equal KX squared, didn't I? And then I just kind of translated over what they were using in the equation in the problem. So let's look at B. How many houses could be served by a water main diameter of 30 centimeters? So I want to make a little I because there's 3 parts here. 30 centimeters. How am I going to figure out how many houses that would serve? Well, I'll plug it in, right? 30 centimeters is the diameter. I know that's not a house. So 30 centimeters wouldn't be a number of houses. That's the diameter. So I go, okay, h equal 1/2 d squared. I'm using this equation up here in A, but my diameter this time is 30 squared. So what's a half? What's 30 squared? 30 times 30 is 900, right? What's half of 900? This will serve 450 houses. If they want to know how many would be served by 43 centimeters, all I'm going to do is plug that into that equation. I'm not going to do that here. I'm going to leave that for you because this might be a good one for me to grade. But we'll talk about, we'll kind of set some things up here in case you need to go back. Look at the third one, though. There, they want to know 1 meter. Now notice this equation has been given in centimeters, has been the diameter, so I need to know how many centimeters are in a meter. Am I going to plug 1 into the equation? How many centimeters in a meter? 100 centimeters. So what I'm going to do is I'm going to take that equation. If they want to know for a meter, if they want the diameter of the pipe to be a meter, I'm going to be plugging in 100 squared there, and then I can tell how many houses that serve. That's going to be a half of 10,000. So we can tell right now that's going to be 5,000, right? Do you see that if I get the equation written, then I can just plug different values in there and, I don't know how many of you got Part C, they say a new subdivision of 1,500 houses is being planned. So that's how many houses we need to serve. What size of water main would be needed? Is this 1,500 houses, is that H or is that D? H. So we're going to plug this in for H. So sometimes they're going to give it to you the easy way, but then on the last part of the problems, usually what they're doing is having you go, okay, be careful. This is how I might want to use this. I'm sure this is how the city planners and people planning the Liberty Hill thing had probably had to think too, is how many houses am I trying to serve with this? So let's say they said they had 1,500 houses to serve. They're going to put 1,500 in for H, and that's times a half times D squared, right? So what they're asking me here is what size water main is needed. Remember, we measure the size of the water main by the diameter. So they're really asking me what's the diameter of this water main. How am I going to solve this? Solve for D. So let me circle it. So when I solve, if you remember, what I got to do is do PEMDAS backwards. So I'm going to add or subtract anything to get it away from D that I can, but there's not anything added or subtracted from D, so I can't really do anything there, can I? What about multiplying or dividing? D squared is multiplied by a half. How do I get rid of a fraction when it's multiplied by a number? I could say the opposite of multiplying by a half is dividing by a half. Then I have an ugly, ugly, ugly thing up there. Yeah, if I multiply the reciprocal, it'll make my life easier, won't it? So to get rid of a fraction in front of a variable, I could multiply by the reciprocal of 1/2 is 2 over 1, and that's just 2. So now I have 2 times 1,500 is, wouldn't that be 3,000? Okay. So 3,000 is equal to D squared. Well, that still doesn't give me my diameter. How am I going to find just D? I don't want D squared. Yep, so I've got to square root both sides to get the D the way I want it. Okay, yeah, so you want your calculator, the square root of 3,000. Okay, so if we do the math on that, we get about 54.77, so we'll just round to the nearest hundredth, okay? So my diameter of my water main needs to be about 54.77 centimeters in order to serve 1,500 houses. So do you see that you got to really think about, well, you got this equation, are they giving you houses, or are they giving you diameter? You got to plug it in the right spot and then just solve for the other variable. Is this really all that hard? It's really not, okay? A lot easier than a lot of what you've been doing lately. So kind of, instead of going, kind of look, okay, hey, this is a little easier. All right. So number 7, it says in chemistry, you learn Boyle's law. How many of y'all had chemistry yet? Okay. Boyle's law states, let's write this down, that a volume of a fixed amount of gas, we'll call it V, is at constant temperature. I'm just going to add that in since it's in parentheses. Is equal inversely proportional. So what kind of equation Yeah, we're talking about something like y equal k over x, except our y here is volume is inversely proportional to the pressure of the gas. So the x, instead of calling it x, let's call it pressure, because they're going to give us the pressure of the gas. And what's going to go on top? The k. That's my constant of variation. It's the thing that I just don't know yet. Okay?
You know that's basic.
Hay says, write the particular equation expressing volume in terms of pressure. I know I got to start with this V equal K over P. If a pressure, okay, let's think about this. Normally a point would be X comma Y, right? But we decided our Y was actually volume, so that's going to go here, and my X was actually pressure. So my points are going to look like, give me a P, I'll tell you a V. Okay? And so if you look at A, that's what they're going to do so that we can figure out what our constant is. Because the thing about it is we don't really have an equation until we know what that K really is. So it says write the particular equation expressing volumes in terms of pressure. If a pressure of 46 pounds, okay, so they're telling me, they're giving it to me in pounds, and it's 46 down here is the P for pounds, compresses the gas to a volume of 360 cubic feet. So it looks to me like they're giving the volume in cubic feet. I'll put feet cubed. And aren't they giving me the pressure in pounds? I'm just going to kind of note that because, you know, the last one they messed with us a little bit with units, didn't they, on that 100, what a meter, or we had to change it to 100 centimeters or something, okay?
Does it stand for pressure or does it stand for pounds?
Pressure, it just happens to be measured in pounds, so it's kind of like a double, that kind of helps a little bit when we see something with pounds. Okay. All right, so if I want to find my K, how am I going to find the K? K by itself, okay. Now there's a couple things I could do here. We talked about in the last section that if I've got a fraction on one side and I got an equal sign, and if I can create a fraction on the other side like this, then I could cross multiply. That would be one way to solve it. The other thing I could do, I could say, well, K is divided by 46, so to get K by itself, I could just multiply both sides by 46, right? So bless you. You could think of it either way. What I'm going to do, just because you might not have thought to make it into a proportion, what I'm going to do is just say K is divided by 46, so to get K by itself, let's multiply both sides by 46. So I'd get K equal whatever 360 times 46 is, 16560. Oh, there's my constant. And I can write my equation. P equal K over P. But now I know that what K is, okay? I'm going to go to a new slide. I did just write in V equal K over P. Now I know that it's V equal 16560 over P.
Oh, graph.
Okay, so moving on. Plot a graph of volume versus pressure in the domain from 10 to 100 psi. And remember, that's our pounds, that's our pressure. So all they're telling me is basically go to your graphing calculator, type in this equation. When I type it in the graphing calculator, I don't probably want to go use V's and P's because they're kind of hard to get to. So I could just write this in as y equal 16560 divided by x. That's what I would type in my graphing calculator, and I could get a little graph of it, and what you're going to do is just sketch it on your paper, okay? So we're running out of time. You could do that at home and sketch it on your paper. They want you to sketch it from 10 to 100, so maybe you want to count by tens, 10, 20, 30, 40, 50, all the way to 100, and then just sketch that graph, okay? That's because you're... Yeah, you're probably going to have to change your x's. You remember your domain, your input.